Imperva is the cybersecurity leader whose mission is to protect data and all paths to it with a suite of integrated application and data security solutions. Learn more at imperva.com.
At Level Blue, we simplify securing your most valuable business assets by providing broad cybersecurity experience and award-winning services. Level Blue manages the risk. You reap the reward. Learn more at levelblue.com.
When the coders don't code, what happens when AI coding tools go dark? And what about when the coders aren't, well, really coders at all? We've all seen the flood of claims about developer productivity. Anecdotes and headlines declare that AI coding tools are making engineers 10 times faster, cutting out 80% of the boilerplate, and enabling teams to launch full apps over a weekend. These numbers are attention-grabbing, and to be fair, many developers do report significant improvements in speed and efficiency, especially when working with tools like ChatGPT, Claude, GitHub Copilot, or Replit Ghostwriter. However, most of these claims are based on anecdotal experience, company internal benchmarks, or aspirational marketing, rather than peer-reviewed, independently validated research. So, let's pause for a moment and ask a different set of questions. What happens when those services go down? What happens when the complexity of the system being built exceeds what the tools can handle, and developers haven't been keeping track? What happens when the systems themselves, the ones built with these AI copilots, are the ones that fail, and no one fully understands how they were assembled? Mind you, these aren't just rhetorical questions. They actually sit at the intersection of availability, resilience, and cybersecurity. Three pillars that are often discussed separately, but are tightly interwoven in real-world operations. Availability. When your AI toolchain breaks. For many engineering teams today, coding tools powered by AI are not just accelerants, they're dependencies. And dependencies create risk. JP Morgan Chase, for example, reported a 10 to 20% efficiency increase among its engineers using AI coding assistants. While this suggests meaningful productivity gains, it also underscores the growing dependency on these tools to maintain delivery velocity. This naturally raises the stakes if those tools become unavailable. And that's just during normal operations. What happens when these outages coincide with a high-pressure moment, such as a feature freeze, a production bug, or a last-minute patch to stop an exploit? What happens when the tool fails and the human behind the keyboard was never asked or expected to understand the code being generated? Resilience. Who owns the logic? We often talk about resilience in systems terms. Do you know if your app can survive a region failure? Will it gracefully retry? Can it self-heal? However, there's another layer of resilience worth exploring here. The resilience of the team that builds and maintains the system. If the cognitive load of development is increasingly offloaded to AI agents and copilots, and if those agents build logic that's only understood in the context of a transient prompt, what happens to long-term maintainability? Can a developer debug a function they didn't write and maybe don't even understand? Can a team recover from a cascading failure when the glue code was stitched together by something that's no longer available? Can we trace the lineage of a critical piece of infrastructure as code to determine whether it contains a vulnerability, hard-coded secret, or architectural flaw? In other words, are we introducing non-human legibility into systems that still require human stewardship? Cybersecurity. Who secured what and how? Security teams already struggle to gain visibility into what has been deployed. This is especially true in fast-moving cloud-native environments. Now add another layer of abstraction: systems built by AI using components selected by AI with configurations suggested by AI. Two immediate concerns arise here. First, code provenance and trust. If the AI agent pulled in a third-party library or wrote custom cryptography, Bad idea. How do we know? If it left a misconfigured port open or ignored a secret management best practice, where's the record? Did it follow cybersecurity and privacy and other regulatory/policy best practices? How often do you check? And what do you see when you do? Second, incident response under opacity. In the event of a breach or anomaly, security engineers typically go spelunking through logs, repos, and architecture diagrams. But if the architecture was created via a series of ephemeral prompts, and no one saved the session, what are they looking at? How do they reconstruct what the system is, let alone how to fix it? This complexity is amplified when systems are not built exclusively by trained engineers. At a recent legal technology conference, I saw a surge of law firms giving their lawyers the ability to vibe code new applications using natural language AI, assistance for internal tools, client dashboards, and document workflows. The motivation is clear: do more with less, automate creatively, and empower professionals at the edge. But it raises a critical question for security teams. When citizen developers build functional software outside formal DevSecOps oversight, how do you assess and secure what's being created? In my redefining cybersecurity conversation with Izar Terendach, he warned that the same vibe coding trend can rapidly create unseen vulnerabilities. We may be giving up too much too soon. Perhaps it's not up to where it should be for us to start giving it mission-critical responsibilities. Treat code from a machine like code from a junior developer. Review it, test it, and never assume it's secure just because a machine wrote it, he said. We already have issues with shadow IT and orphaned infrastructure. Are we about to witness a wave of shadow logic with critical behaviors embedded in systems that no one remembers requesting? Incident response. Time is everything. Perhaps the most critical dimension here is what happens during a live incident. Time is compressed. Stakes are high. The team is scrambling to understand the blast radius. If your AI tooling is down and the system in question was largely created or maintained with its help, then incident response becomes a forensic exercise with half the tools missing. What's running? What's failing? Who touched what? And when? How do we safely shut it down or bring it back up? And if you have an AI-generated system responding to incidents, think autonomous remediation workflows, but that agent is now unavailable or behaving erratically, are you compounding the chaos? We're told AI will augment humans, not replace them. But augmentation without understanding creates its own kind of fragility. This isn't fear-mongering, it's a call to assess risk. To be clear, this isn't a rejection of AI coding tools. They're extraordinary. They're unlocking velocity and creativity at unprecedented scales. To be clear, this isn't a rejection of AI coding tools. They're extraordinary. They're unlocking velocity and creativity at unprecedented scales. They're helping small teams build like large ones, and large teams move like startups. But we can't ignore the operational and security implications of becoming overly dependent on systems that may be transient, black-boxed, or externally controlled. The questions we need to ask ourselves include: what is the contingency plan when our AI tools go down? How do we document and validate AI-generated code and configurations? Who is responsible for the logic created by these tools? And how do we assign ownership? What processes do we have in place for reconstructing decisions made by non-human actors? How do we train engineers to think with AI, but not become reliant on it to the point of helplessness when it fails? We already conduct tabletop exercises and red team simulations. Perhaps it's time to simulate AI failure scenarios, such as outages, hallucinations, misconfigurations, or adversarial prompt injection, so that we can identify and address what breaks. Join the conversation. If you've worked through one of these scenarios, or are thinking about how to prepare for them, I'd love to hear from you. Please note that this newsletter isn't just about raising alarms, it's about surfacing realities. We're at the beginning of a new kind of software development lifecycle, and the questions we ask now will shape how resilient our systems and teams are in the future. Drop a comment below or tag us in your posts. What's your perspective on this story? Want to share it with Sean on a podcast? Let him know.
ThreatLocker is a zero-trust endpoint protection platform providing enterprise-level cybersecurity to organizations globally. With ThreatLocker, you only allow what you need and block everything else, including ransomware. Learn more at threatlocker.com.
Imperva is the cybersecurity leader whose mission is to protect data and all paths to it with a suite of integrated application and data security solutions. Learn more at imperva.com.